So today we're going to go over chapter 3, section 2, using parallel lines and transversals. Okay guys, so let's go over the postulate and the theorems. If two parallel lines are cut by a transversal, then we have corresponding angles are congruent. That's a corresponding angle theorem. We have the alternate interior angles are congruent. That is the alternate interior angle theorem. Then we have the alternate exterior angles are congruent. That is also a theorem. And the consecutive interior angles are supplementary. So it's a consecutive interior angle theorem. Guys, I want you to realize that in your notes, the corresponding angles, you have that it says postulate. Please change it to theorem. And guys, please remember these four. We will use them in proofs. So we have this example. It says find the measure of each angle. Guys, I want you to realize there are two transversals here. So we're going to use the special, I'm going to write them down. We're going to use the special angle pairs. We're going to use the linear pair postulate. We're going to use the vertical angle theorem. Now we're going to use this on top of what we just learned right now. So, I want you guys to notice. You see this right angle and this right angle? They're telling us that, so also realize that this is a right angle, this one right here. All of these are right angles. Same for these four. So if they're telling us that, we can say, well, those four are 90-degree angles. So now let's figure out what's going on. I'm going to give measures to these angles since they don't have any, so we can work them out. I'm going to say that angle 1 is 50, and I'm going to say that this one is 130. Now, how did I get that 50 for angle 1? You guys realize that 130 and this angle are corresponding, right? So because there's corresponding, angle 2 is also 130. And since angle 1 plus angle 2 is a vertical angle, so the last vertical angle theorem that we said right here, I can do 180 minus 130, and I'm going to get 50. That's how I get measure of angle 1. I don't know why I wrote 15, I meant to write 50. Now, because of that, you're actually able, just with one angle, you're able to solve all of these. In this case, they gave us 130. So we just have to subtract from 180 to find its pair. In this case, we realize that angle 2 is 130 because, again, they're corresponding angles. So we just subtract that from 180 to get angle 1. Now, we already have angle 2 because we realize that it is corresponding, so I'm just going to write 130. Now, angle 3 is supplementary to angle 1, right here. It's also a vertical angle to angle 2, so it's also 130. 4 is supplementary to angle 2, but it's also vertical to angle 1, so angle 4 is also 50. Now, angle 1, right here, and angle 5 are corresponding. Again, they have the same value. So we can say that angle 5 is 50. We can say that angle 6, again, is corresponding to angle 3. It's supplementary to angle 5 and is vertical to the given angle. So we can say that it's 130. Angle 7 is vertical to angle 5. It's supplementary to the given angle. So we can say it's 50. And then angle 8, they gave it to us by giving us a 90-degree angle, so that one is just 90. So I'm not going to explain it right this second. I'm going to give you guys a minute or two to answer it, but I'm just going to highlight what I just said. These two angles are parallel. They give it to you with the two little triangles. The only given angle is 110, and they're asking you to solve for x, y, and z. Alright, so I want you guys to realize that this x is actually corresponding with the supplementary of 180. So to get x, the easiest thing that you could possibly do is just do 180 minus 110. And you're going to get that x is equal to 70. Now, for y, I'm going to write it in here. Now, I want you guys to realize that this angle, 2y, and this x, they're corresponding, so they are the same thing. We can say 2y is equal to 70, so we can divide both sides by 2, and we're going to get that y is equal to 35. And lastly, I want you guys to remember the theorem that we mentioned at the beginning, that the two interior angles add up to 180, right? I also want you to realize that there's two options to solve for this. We also have the 110 and the 2z as being corresponding. You can either add both of the angles, so 70 plus 2z equals to 180, or you can do 2z is equal to 110. I'm going to go ahead and do 2z is equal to 110. So when I divide both sides by 2, we are going to get that z is 55 degrees. Now, if you were to have done it the other way, so 2y is 2 times 35, which we know it's 70. So 70 plus 2z equals 180. If we were to do it that way, subtract the 70 from both sides, we're going to get 2z is equal to 110, which one we divide by 2, and we still get that z is equal to 55. So whichever method you choose to use, it's okay. As long as you use the theorems, you will get the same answer. Okay, so this is example 3. When sunlight enters a drop of rain, different colors of light leave the drop at different angles. This process is what makes a rainbow. So for violet light, angle 2 is 40. What is the measure of angle 1, and how do you know? So I'm going to write in the information. Angle 2, they're telling us is 40 degrees. And they want us to find angle 1. So the first thing I want you to notice in order to be able to solve for this problem is that these two lines are parallel. That's great for solving for angles and different measures because we can just get that they are the same, which is awesome. Now, angle 1 and angle 2, you notice they are alternate interior angles, right? So because they're alternate interior angles, the measure of angle 1 is just going to be 40 degrees. And we know this, again, I just said it, alternate interior angles. Before I do proofs, I always like to work it out in the diagram. So they're giving us that the parallel lines are P and Q, and they want us to prove that angle 1 and angle 2 are congruent. Obviously, we know that interior angles theorem is congruence theorem, but we're going to go through 4 steps to prove that the theorem is correct. Now, we already proved that corresponding angles are congruent, and we already proved that vertical angles are congruent. So we're going to use those. Now, I realize we have this transversal, and that separates my 3 angles into their respective spots. Now, we have angle 1 and angle 3 are corresponding. And we already proved that. So that could be our first step after the given. And then we can say, well, angle 3 and angle 2 are vertical angles. So we can say that those two are congruent. And then afterwards, we can say, well, if angle 1 and angle 3 is congruent, and angle 3 and angle 2 is congruent, we can use a transitive property. So that way, I just proved it with the diagram. Now let's write it down. We have a statement, and we have a reason. So for statement number 1, I'm going to write P is parallel to Q. So that is given. Then for the second one, like I said, angle 1 and angle 3 are congruent. We figure that out because they're corresponding angles. Now we have step 3, which is angle 3 and angle 2 are congruent because they are vertical angles. And question 4 is angle 1 is congruent to angle 2 because of the transitive property. Now, just as a quick reminder, remember the transitive property kind of gets rid of the middle number, so we just end up with angle 1 is congruent to angle 2. Now, we just proved that interior angles are congruent. You guys do have homework on big ideas.